Deep neural networks excel at recognizing patterns and making predictions, but when it comes to image recognition tasks, they often struggle to distinguish between the images of similar individuals. The triplet loss, a powerful training technique, was developed to tackle this issue by learning a similarity metric that accurately embeds similar images too close to each other in a high dimensional space. So in this video, we'll break down the triplet loss and its variant, the batch triplet loss, in a simple technical terms, and will provide a relatable example to help you understand the concept. So let's get started with what is a triplet loss. Basically, triplet loss is a loss function used in deep learning based approaches for training neural networks to perform tasks such as face recognition or object categorization. The goal of triplet loss is to learn a similarity metric in a high dimensional embedding space, also called as feature space, where similar objects or the images of same person are represented close to each other while dissimilar objects are further apart. And the key concept of triplet loss is the use of triplets, which consist of an anchor, a positive and a negative sample. Here the anchor and positive sample are the similar instances while the negative sample is dissimilar. The algorithm learns to embed these samples in a way that the distance between the anchor and positive sample is smaller than the distance between the anchor and negative samples. So in practice, triplet loss is often used in conjunction with a neural network architecture called as Siamese network, which shares weights between two or more branches that process the same input. And this shared representation allows the network to learn a robust similarity metric in the embedding space. Now to summarize this, we can say triplet loss function penalize the network when the anchor and positive samples are not close enough in the embedding space, while anchor and negative samples are too close. And this encourages the network to learn a meaningful representation of the input data that captures similarity between the related samples. So imagine you have a set of photos of different people and you want to train a face recognition system. Now the goal is to identify whether two images belongs to the same person or not. Triplet loss can be used to learn a similarity metric that allows the system to accurately recognize faces. In this example, the triplet consists of three photos: an anchor, a positive and a negative. Now anchor is a photo of specific person, the positive is another photo of the same person, and negative is the photo of different person. So during training, the network is presented with triplets, and the triplet loss function calculates the distance between the embeddings or the high dimensional feature representation of anchor, positive and negative samples. If the distance between the anchor and positive embedding is too large, or the distance between the anchor and negative embeddings is too small, the triplet loss function will penalize the network. And by iteratively adjusting the network's based on this loss function, the network learns to embed similar faces, that is the anchor and positive, close to each other in the embedding space, while dissimilar faces, that is the anchor and negative, are separated. For instance, if the embeddings of two photos of the same person, that is anchor and positive, are close to each other, then the system can accurately recognize that they belong to the same person. Conversely, if the embedding of the photos of different people, that is anchor and negative, are far apart, the system can confidently classify them as belonging to different classes or the different individuals. Now, what is batch triplet loss? Now, this batch triplet loss is a variant of the traditional triplet loss that operates on batches of data during training. So, in the standard triplet loss, a batch consists of three images: an anchor, a positive and a negative. And the goal is to learn a similarity metric that allows the system to accurately recognize faces. In batch triplet loss, instead of processing triplets one at a time, multiple triplets are processed together in a single batch. And this approach can be computationally more efficient and can leverage the power of modern GPUs to train deep neural networks more quickly. So during training, the network is presented with a batch of triplets, and a triplet loss function calculates the distance between the embeddings or the high dimensional feature representation of anchor positive and negative samples within each triplet. Now the Batch Triplet loss function will penalize the network if the distance between the anchor and positive embedding is too large, or if the distance between the anchor and negative embeddings is too small. And by iteratively adjusting the network's weights based on this loss function, the network learns to embed similar faces, that is the anchor and positive, close to each other in the embedding space, while dissimilar faces, that is the anchor and negative, are separated. For example, if the embeddings of two photos of the same person, that is anchor and positive, are close to each other, then the system can accurately recognize that they belong to same person. Conversely, if the embedding of photos of different people, that is anchor and negative, are far apart, system can confidently classify them as belonging to different individuals. And this Batch Triplet loss is an effective method for training deep neural networks for face recognition and other applications where a similarity metric is needed. So imagine you are a security guard at an airport and your task is to identify individuals as they pass through a security checkpoint. You are provided with a handheld device that displays 3 photos at a time, an anchor, a positive and a negative. And your goal is to quickly determine if the person in the anchor photo is same as the person in the positive photo, and if they are different, you need to identify the person in the negative photo. And this scenario can be framed as the Batch Triplet loss function, where the handheld device is essentially performing a deep neural network that has been trained using Batch Triplet loss. The anchor, the positive and negative images are the inputs to the network, and the output is a set of embeddings or high dimensional feature representations that capture the similarity between the images. Now this network is trained to minimize the distance between the embeddings of same person, that is positive pair, while maximizing the distance between the embeddings of different people, that is negative pair. So in this security scenario, when the handheld device presents you with a batch of triplets, the network calculates the distance between the embeddings of anchor, positive and negative images within each triplet. If the distance between the embedding of anchor and positive images is small, you can confidently say that they belong to the same person. Or if the distance is large, you can identify the person in the negative image as a different individual. So by training the network with a large data set of images using Batch Triplet laws, it learns to embed similar images, that is images of same person close to each other in the embedding space, while dissimilar images or the images of different people are separated. And this allows the network to accurately recognize individuals and perform the crucial security task efficiently. Thank you.